Use the less than, greater than, or equal to symbols to make the statement true. In problem 5, we have a decimal representation and a fraction representation. If I multiply the numerator and denominator by 2, that would give me 8/10, which could also be written as 0.8. So this is an example where they are equal. Remember, if you open to the larger one, so less than or greater than. Complete the remaining 5 problems for your warm-up. Here we see the temperature in City A is 2 degrees Celsius. The temperature in City B is less than 2 degrees Celsius. What are some options for the temperature in City B? Well, if it's less than 2 degrees Celsius, it could be 0 degrees Celsius. It could also be negative degrees Celsius. The temperature in City C is greater than 2 degrees Celsius, so it could be 3, it could be 15, it could be 45, or 10, as long as it's greater than 2. In problem 1, it represents it shows a number line, and our job is to start by writing an equation that represents the temperature and then graph it. So the temperature in City A is 2 degrees Celsius. Let A represent the temperature in City A in degrees Celsius. Write the equation that represents the temperature in City A. Well, we're using the letter A to represent City A, and it is 2 degrees Celsius. Then graph the solution to the equation on the number line. So we're putting a dot on 2. Remember, we want the dot to be on the number line. We don't want it to be up here or down here. We want it to be on the number line where those lines cross. The temperature in City B is less than 2 degrees Celsius. Let B represent the temperature in City B in degrees Celsius. Write an inequality that represents the temperature in City B. So we want B to be less than, so we're using the less than symbol, 2 degrees. Then graph the solution to the inequality on the number line. So we could put our dot here, or here, or here, or here, all the way along this number line, because all of these represent values that are less than 2. So we can fill in this whole section with a bunch of dots. But the way that we're going to represent inequalities on a number line is using an arrow. So we're going to demonstrate that all of these values, and we're pointing to the values that are less than 2, all of those values could be possible temperatures for City B. It can get really, really close to 2, like 1.99, but it can't get to exactly 2. So instead of putting a dot on 2, we're going to put an open circle on 2 to show that we can get really close to 2, but we can't get to exactly 2. The temperature in City C is greater than 2 degrees Celsius. Let C represent the temperature in City C. Write an inequality that represents the temperature. It is greater. City C is greater than 2. So we want our symbol to open towards the bigger thing. C is bigger than 2. So it could be 3, or 3.5, or 4, or 4.1, or 4.3, or 4.4. All throughout here, there's going to be a bunch of values that are possible for City C's temperature that are all greater than 2. So we're going to draw our line pointing towards the ones that are bigger than 2. And we can get really, really close to 2, like 2.01, 2.001, 2.0001, but we cannot get to exactly 2 because it needs to be bigger than 2. So we're using that open circle on 2 to show that we can get very close to 2, but not exactly 2. For problems 4 through 6, graph the solutions to the inequality on the number line. So we're putting our dot open on 0 because we can't get to exactly 0. And it says x is greater than 0. So we want to point to the numbers that are bigger than 0. And those are all the values on the right side. This one says y is less than -3. So we can't get to -3, so we put our open circle on -3. If y is less than -3, we need to point to the numbers that are less than -3. All the numbers that are less are to the left. This one says 5 is bigger than z. So we're putting our open circle on 5. If 5 is bigger than z, that would mean z is smaller. So we need to point to the numbers smaller than 5. So how would we say that? 5 greater than z or 5 is greater than z? Well, this phrase, 5 greater than z, would indicate 5 more than z. But if we say 5 is greater than z, that would indicate this inequality. So this one represents the expression, and this one represents an inequality. Can we interpret these, or do they mean the same thing? This one says 5 is greater than z, and this one says z is less than 5. You can see that the symbol opens towards the 5 in both of these cases. So they do mean the same thing. If 5 is bigger than z, then that means z is the smaller one. This one says z is less than 5, so z again is the smaller one. We can rewrite them in the other format if you prefer to have the variable on the left. You just want to make sure that you open your symbol towards the same value. The number lines in problems 7 and 8 each show the solutions to an inequality. For each problem, write 2 inequalities that each represent the solution graphed on the number line. Use x as the variable. So this is going to use the number 5 because I have the 5 here. X is pointing all the numbers left or less than, so x is less than 5. We are asked to write 2 inequalities that each represent this. So the other way we could write it is if it's open towards the 5, we could say 5 is greater than x. Down here, we have x, and the number is -3. This time our arrow is pointing to all the ones bigger. So x is greater than -3. If we swap the symbols or the numbers in the symbol around, we need to make sure that it's open towards the x still. So this would say negative 3 is less than x. Which of these values could I replace w with in this inequality to get a true inequality statement? Well, let's start with 0. If I replace the w with a 0, 8.2 times 0 is 0. So is it true that 0 is less than 14.6? Yes, 0 is smaller than 14.6. So this one is a solution to the inequality. Let's check the next one. If I replace the w with the number 4, is that smaller than 14.6? Well, let's try it. 4 times 2 is 8. 4 times 8 is 32. We have one decimal spot, so this would be 32.8. Is 32.8 smaller than 14.6? Well, no. 32.8 is not smaller than 14.6. What about if we replaced it with 7? 8.2 times 7 is, that would be 14. 7 times 8 is 56, plus one more makes 57. Is 57.4 less than 14.6? No. As we continue to replace w with values that are larger and larger, we're going to continue to make this side of the inequality greater and greater. And we don't want this to get any bigger because it needs to be smaller than 14.6. So the only one that makes this inequality true in this list is 0. For parts A through E, consider the numbers 0, 2, 8, 20, and 35. Which of the numbers are solutions to x plus 3 is greater than 5? Is 0 plus 3 bigger than 5? No, because 3 is not bigger than 5. What if I replace the x with the 2? Is 2 plus 3 greater than 5? Well, 5 isn't bigger than 5. It's the same. So no, that one doesn't work either. What about if we replace the x with 8? 8 plus 3 is 11. 11 is bigger than 5, so 8 works. What if we replaced it with 20? 20 plus 3 is 23. 23 is bigger than 5, so 20 also works. Let's try replacing it with 35. 35 plus 3 is 38, and 38 is bigger than 5, so 35 is a solution. Which numbers are solutions to 30 is less than 75 minus n? If I replace n with 0, that would say 30 is less than 75. That is true, so 0 works. If I replace n with 2, 75 minus 2 is 73. 30 is still less than 73, so 2 is a solution. 75 minus 8 is 67. And 67, 30 is less than 67, so 8 is a solution. 75 minus 20 would be 55. 30 is still less than 55. What about if I subtract 35? 75 minus 35, that would be 40. 30 is less than 40, so that would indicate that 35 is also a solution. Okay, so let's look at C. If I replaced P with a 0 here, anything times 0 is 0. So is 0 greater than 36.4? No. What if I replaced P with a 2? 5 times about 2 would give us 10. 10 is not greater than 36. What about 8? Well, 5 times 8 would be 40, so that would be larger than 36. We can start to use some number sense to evaluate these expressions, rather than checking every single possible solution. If I continue to make P bigger, 5 times 20, that's going to continue to get bigger. So that would mean 20 and 35 would also be solutions, because the larger I make this side, it's going to still be bigger than 36. Let's check here. 0 divided by 2. Well, that's 0. And this side, 5 minus 4 is always going to be 1. 0 is less than 1, so 0 works. What if we replaced it with the 2? 2 divided by 2 is 1. 1 is not less than 1, so 2 does not work. If I used 8 here, 8 divided by 2 is 4. 4 is not less than 1. So the larger and larger I make m, the larger this side is going to get, and it's not going to be smaller than 1. Suppose the product of 2/3 and x is less than 0. Which of the numbers could be the value of x? Explain. Well, if we put a 0 in here, 2/3 times 0 is 0. 0 is not less than 0. And if I replace this with anything larger than 0, I'm going to get something that gets bigger and bigger. So none of these values will make the inequality sentence true. Ryan buys a drink and a snack at the concession stand. He spends less than $5. The price of Ryan's drink is $1.75. Let P represent the price of the snack in dollars. Write an inequality to represent the situation. He had P for his snack, the price of his snack, and he also bought a drink for $1.75, and he needs to spend less than $5. Which snacks does Ryan not buy? Explain. Well, he can't buy chicken strips, because that would already be the maximum amount of money he has. And he can't buy a hamburger, because $4 plus $1.75 would be too much. Let's check the nachos. $3.25 plus $1.75. That is $5. But he spends less than $5. Not exactly $5. So he can't buy the nachos either. But he could afford anything cheaper than the nachos. A box of crackers costs $3. Sasha must spend less than $20 on crackers. Let C represent the number of boxes of crackers that Sasha can buy with $20. Which inequality can be used to determine the number of boxes of crackers that Sasha can buy? Well, she's getting $3 each, and she wants to spend less than 20. So that would be C. Which statement correctly describes the number of boxes of crackers that Sasha can buy? Well, if we did 3 boxes, 3 times 3 is 9. So she could get 3 boxes or fewer. 3 times 6, that would be 18. 18 is still smaller than 20, so she could get that much. 7. 3 times 7 is 21, so she can't buy 7 or fewer. Sasha can buy 19 or fewer. 3 times 19 would be much more than $20. So B would represent the best statement. She could buy 3 or fewer, but we want to see how much she can buy. At most would be 6 boxes. That's the end of lesson 18. Check back for future lessons and make sure that your workbook is filled in.